Hi everybody, this is Brooke Bacon. I just wanted to let you know that our webcast will be starting shortly. We are just going to give you a brief overview of GSI while you wait. So who is GSI? GSI is a full-service consulting and managed services organization with deep application and industry knowledge. This deep knowledge allows us to develop advanced AI and automation that delivers cutting-edge intelligence. This unmatched intelligence is what enables our clients to thrive and not just survive. So why partner with GSI? GSI is a full-service ERP, SaaS, cloud, ITSM, cybersecurity reseller, consulting, and managed services organization. We have industry, application, and technical certifications, and we not only understand the business system you are utilizing, but most importantly, the industry. Advanced AI and automation are used in all of our products and services to help our clients reduce TCO and increase ROI. We have offices nationwide and partners worldwide, which allows us to offer a 24/7 global support model. And we are the only partner you will find in the industry that has a 100% guarantee on everything we do. Here are a few of the awards and accreditations and certifications we have received. Our mission is to make every customer a client. To accomplish this mission, we create a culture that attracts and retains the most creative, energetic, and experienced professionals. Here are some of the products that we have developed to help our clients thrive. Genius AI is a platform designed to support the development and execution of customized modules for system monitoring, application monitoring, AI, and automation. Modules can be developed and executed for almost any business system. Our clients use Genesis Performance Optimizer to model, measure, and maximize system performance for all of their web-based business systems. Genome is our newest product that will detect, analyze, and automate the process of converting customizations into orchestrations. Rapid Reconciler is our tool that reconciles perpetual, in-transit, and received not vouchered inventory. Rapid Approval is an application for quickly processing workflow approval requests in Salesforce. And G Shield is a line of security products that we are continuing to expand. Currently, we have two products, JDE Password Reset and JDE Two-Factor Authentication. As you can see from these testimonials, our clients attest to the fact that we focus on the business value of their systems, not just the performance. This business value focus allows our clients to transform antiquated systems of record into market share expansion machines.
Hi, this is Bill Rem with GSI, and this is J.D. Edwards Database Blocking, 5 reasons why your application is causing database blocking and how to fix it. I am currently a database administrator on Oracle, SQL Server, and several other databases. I've been a JDE CNC since 1998. Took a little stint as a JDE developer as well. Do a little bit of data scientist stuff and have a couple of certifications under my belt. Before we get started on what causes blocking, let me tell you a little bit about blocking in general. Number one thing is blocking is not bad. It's actually a beautiful mechanism by which the database protects itself and your data from getting corrupted. Now, all blocks start out as locks, and these locks happen hundreds of times per minute or even per second, depending on how busy your database is. And these locks prevent multiple writes from occurring simultaneously, and sometimes also prevent some read operations. But it's how the database ensures transactional integrity by making sure that nobody not only overwrites something, but that they also don't read information that's out of date. This is all related to ACID properties of transactions, a little bit out of scope for this presentation, but if you look it up, that'll describe the concept of database transactional integrity. So when should you care about blocking, just in general? And that is not always going to be when a block alert comes in. It needs to be more than just the alert. There has to be something associated with it. So if you have users complaining about performance issues and you get a blocking alert, then that you want to care about that a lot. Also, automatic alerts from other things like the operating system or from executions of some other process, a database performance alert that are also associated with a blocking alert, those are going to raise it to the level of something you need to take care of right away. Now, there are sometimes applications and processes that you know are always going to be blocking, and normally you keep track of those. It's different for every company, but if they go on too long, then you might want to look into it and make sure that there's nothing bad going. And then, of course, if database maintenance is going on, there are certain types of database maintenance that can slow things down and create blocking where there wasn't any before. So if you get a block and you know that you're doing a reindex job or something like that, then that is going to be something you want to jump on and maybe kill the maintenance job. So blocking, as I said in the beginning, is good, and there are going to be lots of times when you don't have to care about the blocking. So you get an alert that comes in, but it's not associated with any kind of complaint or performance alert or message. Everyone's happy. Nobody even notices that the blocking is happening, so probably don't have to do anything with that. Or if there's a known long blocker happening, those are going to happen. Depends on your system. Can't really predict it. You just got to get to know it. If one of those pops up and there's no other problems associated, then you don't have to care. And many times you will see transactions come in that block themselves. A transaction will kick off a process, and it'll grab some data, and it'll need to send it to another process, another SQL statement, to grab some more data that it eventually is going to put together at some point. And it only matters to the internal application that the blocking is happening, but the application knows that it's happening and it's not affecting anybody else. So you'll see that a lot, especially in JDE Edwards, where the blocking is just part of the normal process of a specific application. Now, here are the causes of blocking, and in a nutshell, it's your application. Of course, I'm oversimplifying it, but the truth is blocking wouldn't happen if nobody was accessing the database. Of course, it's not very useful to have a database that nobody can access, but the database only uses locks and blocks to prevent applications and users from affecting the integrity of the database. In practice, it's a lot more complicated. Causes of blocking. Whoa, that is a list. That is a big list. And I only said I was going to do 5, so this is too much information. That's too many causes. So the title of this presentation did say something about 5 causes, so let's do that. All right, let's talk about just 5 causes of blocking. And this is based on my experience and my opinion and several other things. But by far the biggest cause of blocking I see, especially with the JDE Edwards application, is when it gets disconnected from the application, JDE application gets disconnected from the database after a SQL statement is issued to do something. So databases just do whatever they're told. If JDE application says, or any application says, don't let anyone modify this record until I'm done, the database says, okay, and it puts up a big stop sign and keeps anything else from happening. But what the database does not know is when or if the application is coming back to give it more instructions. If the application goes down, or a user doesn't complete their transaction, or someone doesn't commit a SQL statement, the database will happily hold that lock forever. And then when something comes in behind that lock for its turn, the database says, nope, the app said to guard this data, and I'm going to do it until I hear otherwise. So that could last a long time. If there's an application disconnects are often caused by network issues, but I'll talk more about that on the next slide. I'm going to go into detail on each one of these. Now the next one is a poorly designed application or a poorly designed SQL statement. And a badly built application or an overly complicated SQL statement can bring any database to its knees. And just because someone can write an application or create a SQL script, it doesn't mean that they can do it well, or nor does it imply any level of understanding about how databases work on their part. Then the next big one is excessive read-only reporting. And a lot of people say, well, you know, we're just reading the data. How can that be a problem? It's because it still requires resources to read this stuff. So if you've got, say, for example, you've got 50 people in line waiting to read a document, it's going to take a long time for person number 51, who maybe wants to write something on that to get their turn. And when that person finally gets their chance to write, 50 more people queued up behind them to do some more reading. Unfortunately, that person writing is going to take an hour to make their changes, and everybody's sitting there waiting to read their stuff. So this can happen on a database, on any database, and almost every company that uses JD Edwards suffers from too much read-only reporting. And that goes kind of segues into ad hoc reporting. It's, there's still, both of these are read-only, but ad hoc reporting, it takes the performance hit to another level. And an ad hoc reporting tool allows users to quickly create their own reports, usually through some kind of drag and drop interface or something else very simple. An orchestrator is kind of a ad hoc sort of reporting tool, but with a little bit more constraint to it. So these tools are made for the average person to easily get what they want. But on the back end, the tool is going to put together whatever gnarly query it needs to make a pretty report. Building a JDE UBE or an orchestration, like I said, can cause similar problems, but I'll get into how the ad hoc reporting tools make issues with the database. And then finally, multi-part transactions. Now JDE Edwards is big with this. Many JDE apps walk users through multiple screens to complete a complex transaction, but only the JDE application itself knows how that transaction is strung together. The database only sees a bunch of sessions and SQL statements coming at it. And because the JDE apps are a loose collection of selects, updates, and commits, a failure at any point in the JDE process could disrupt the integrity of the data. JDE is supposed to keep track of these, abandon transactions, and fix them when necessary, but it doesn't always work correctly, and not all apps are transaction aware. This isn't unique to JDE Edwards. Many other applications do this as well. The problem comes when one part of the transaction blocks something that depends on a future part of the process, but it fails before it gets to that second part. And that picture on the side is a badly generated SQL statement. You can see there's multiple nested loops and full table access and whatnot. And that would fall under the category of a poorly designed SQL. All right, so here's some of the details on fixing blocking. So for application disconnects, I mentioned earlier that those are almost always related to network or end user issues. And in order to diagnose these, they are the most difficult to figure out because you have to pull in a lot of different people to sort out what's going on. You have to have CNC, DBA, you have to have a networking person, your infrastructure, and the end users. They all have to have some kind of input into this. Like I said, virtually all application disconnects are related to network issues, and that's because JDE is very susceptible to fluctuations in connectivity in general. A network disconnect coming up at the wrong time can mess everything up. Some great examples are for when you have something like RF Smart or DSI or something that has a separate server that brings in transactions from scan guns or whatever, and then inserts that into JDE Edwards as part of a JDE, a special JDE transaction. And the issue comes if a DSI transaction or one of these starts and it grabs a next number, but it's not able to update that next number for some reason because the third-party application drops out of the world. Now JDE is kind of stuck holding the bag, and there's nothing to come back and say, please let this database session go. And it all related to something to do with the network dropping out. This could happen to users too. A user could be in a whole other country, and the connectivity to that country could be bad, or maybe you just have an office with a DSL connection, and that drops out. And that could come at the wrong time in a JDE application and cause blocking transaction. Again, we talked about earlier about poorly designed applications, SQL statements. They aren't always created by crazy people. They can come straight from the manufacturer of the application. In the case of JDE Edwards, the way that people are trained in multiple areas, CNC, developer, it causes downstream issues with application development because JDE and its manuals have historically downplayed the need for really any knowledge of how a database works. And plus the application itself is shipped with tools inside the app that allow users to drop tables and change data. On the development side, when you're developing an application, a developer has to select or create an index for when they're doing a fetch select or fetch next. So you'll often see a proliferation of custom indexes associated with custom JDE apps. In addition, there is the open table, fetch single, fetch next, close table, sometimes not followed up by a close table, where there's something inside the app that should have completed the thought on whatever it was doing, and they just don't end up putting it in there. So if there's a lot going, oh yeah, another big thing is because of how JD Edwards works with the enterprise servers running the logic and the SQL statements getting the data, there could be a situation where a SQL statement will go out and select something that a UBE needs or a process in JDE is going to churn on the enterprise server for a while. Meanwhile, it holds that other session on the database, and the longer it's holding this select for update, it gives it more and more time for someone else to come in and need that. So you can create blocking by putting too much processing in between update statements, dependent update statements. Okay, moving on to the next three. Excessive read-only reporting. So JD Edwards was designed as a long time ago for AS400, I think maybe System 370 or something like that beforehand. But it was back before, I don't think that data warehouse and reporting databases and things were as big as they are now, or I don't know if people even really thought about it, but it was designed to have application processing and reporting on the same database. And that it really hasn't changed. There's not been a whole lot of thought put into how best to separate JDE's data from reporting. They kind of leave it up to the database side, and the database stuff, like I said, is really downplayed in the manuals and training for JDE. But what you need to do, the best way to fix this is to create a secondary reporting database using database tools. In Oracle, you'd use something like DataGuard, Active DataGuard, to create a secondary database that you can read from. SQL Server, you would use availability groups, and those are just one way to do it on each. But that creates a up-to-the-minute replicated copy of your data to which you can point all of your reporting. So now, with that setup, you would have all of the performance hits and problems from reporting taken off and moved to a secondary database. Now your people who are running through their applications and trying to get their job done, they're not slowed down by constant reporting, and the people who are getting their reports don't have to worry about the active updates and deletes and inserts slowing down the reporting that they are trying to do. On third-party ad hoc reporting tools, that's going to be management and configuration to fix that. You will have to leverage the application changes to prevent users from doing wide open selects, or force them to use indexes in order to create their reports. And then you're going to have to educate the users a little bit on, when you create a report, don't throw everything in there that you can possibly imagine. Don't do a whole bunch of joins and things, multiple tables and whatnot. And don't select all the data that there ever was. You need to limit your data selection to a certain date or some kind of a range. So you're going to be telling the users that here's the best way to do this stuff, for the most part, on third-party reporting tools. It's some of the same stuff you have to do when you're talking to someone developing a UBE or an orchestration. It's just, I think that the third-party tools care less about how the data is retrieved than they do inside JD Edwards. And now JD Edwards' multi-part transactions causes some issues, and there's really no way to get out of this. It's always going to happen. You're always going to have multi-part transactions. So in this case, you got to educate users on a couple things. One is go all the way through your transaction and get out and finish it. And don't go home for the day. Don't end on the last page and click X and leave. You want to make sure that gets done and you get out so that you're not holding some kind of phantom session on the database. Also, there are some apps where you can get to the end, submit whatever the thing is, and then click back, change it, and then go forward. And that will create another iteration of that will end up becoming a block. In addition, some people will get to a process, either an application thing or a UBE. They'll submit something and it doesn't come back in the time frame that they think it should, and they'll submit it again thinking that that is going to speed things up. But in the back end, it's just adding that in multiple times and causing the system to slow down even more every time as it tries to accommodate all those requests. So don't be tell your users, don't be tempted to resubmit. Make sure they get through everything without stopping or leaving for the day. But wait, there's more. I know I said this was about the top 5 causes of blocking, but I was feeling generous, and today only, we are doubling your order. That's right, you get 10 reasons you're seeing more blocking on your database. Okay, so we get next number sharing. And this is when you're using a third-party application that uses next numbers that are also used by similar applications inside JDE. A good example is the work order next numbers for things like the super backflush program. If you have separate processes like DSI or RSmart that have to enter things in for work orders, they may have a special business function or something that's just for processing their stuff. But what happens with the next numbers is you get a whole bunch of people using these same next numbers, so your next number usage increases significantly. And if there happens to be any kind of a disconnect during one of those processes, well, you'll get a hard block there. But in just using the next numbers, because those are touched for every single transaction on some of these apps, the activity goes up so high that it slows everything down because applications are not able to get their next numbers fast enough. And this could be everything from simple row contention for applications needing the same next number, or block level, database block level contention. And this is because the next number rows are so small they can fit inside of single database blocks. And if you have multiple sessions trying to write to a single database block, it's got to lock that block, that whole block, which could be 5 rows in your next number table. And so you'll get totally unrelated next numbers blocked due to block contention because one of those next numbers is being used 1,000 times a minute. The second one is specific to SQL Server, and it's related to read committed snapshot isolation. That's what that RCSI stands for. Now in SQL Server, the way it's shipped is that everything blocks everything. A read session hides behind, has to wait behind a read session or a write session. It doesn't matter. Now Oracle is by default doesn't do that. It allows readers to read next to other readers. Writes don't block readers either. It just the readers come in and they hope that the data doesn't change. If the data does change, it'll reread it, but it's much faster to have that kind of optimistic locking so that nobody's unduly blocked. I don't know why SQL Server is like the opposite by default, but enabling RCSI is how you fix it. Now, some of you CNCs may know that inside the JDE INI, there's a section for SQL retries and timeouts and things like that. RCSI eliminates that. It's basically a permanent implementation of that no lock timeout thing in the INI. So once you put RCSI on, you don't need to do anything with that SQL timeout stuff. Now, don't confuse recommitted snapshot isolation with snapshot isolation, which is a different setting inside SQL Server. You don't need to enable them both. RCSI is a higher level of isolation than snapshot isolation. So if you have them both on, you don't need that. Now, I wouldn't say go in. I wouldn't say. I say do not go into SQL Server and enable RCSI. There's a lot more to it that needs to be configured in order for that to work well, because it blows up your tempDB usage. It also requires a little bit of downtime. So don't go turn it on because you may end up crashing your database. And speaking of crashing your database, unnecessary database maintenance is a big deal. And this primarily is people want to do index rebuilds all the time. Index rebuilds are not really necessary anymore because of how modern storage works. Everything's kind of fragmented. And then the index rebuild is to defragment your indexes. And nowadays you don't need to defragment indexes unless you have purged a ton of data and you're trying to reclaim some space in the index. So if you have an index rebuild stuff going on in the database, that you don't really need to do that. You need to rely on the built-in database statistics rebuilds, and that's a main primary benefit of doing an index rebuild is regenerating statistics. Now, I wouldn't say that you need to generate all statistics all the time either. Your database has automated processes to update the statistics, and if you need better statistics or more timely statistics for specific tables, then set up a job to do that specifically. Don't do a global job to do that. Other things are, like on SQL Server, there is the dbcc check db. You don't want to do that on your production instance all the time, and various other things. So unnecessary database maintenance can slow things down and cause blocking to occur. In fact, some database maintenance, including index rebuilds, actually causes blocking on its own without even considering the slowdown in performance. Something else that does cause the blocking is poorly configured high availability or replication. That is a good example of that is if you have one of your primary node, your primary database is right there in your office, but for some reason you've set your secondary database at a geographically distant location, maybe across the country or even sometimes even another subnet, but you set the synchronization to synchronous instead of asynchronous. What that means is when you set a replication between two databases to synchronous, both databases have to confirm they have committed the data before it can move on to the next transaction. And if your secondary node is limited in some way due to network or whatever, or it has lower specs or something, then you could have your primary database sitting around unnecessarily waiting for a transaction to commit on the secondary. So in that case, you want to set your high availability as asynchronous so that the primary database isn't constrained by how long it takes the secondary to apply its stuff. And then just in general, all of these things, these last three things I said, are related to your database being poorly configured. But there's a lot more settings inside there that can affect database performance and increase blocking. So there's a general set of best practices and baselining that we do here at GSI that prevents a lot of that stuff from happening. But if you have looked through all of these other things and you're still getting blocking, there could be a database setting that you have missed or needs to be tweaked a little bit to speed things up. Now I'm going to give you some blocking tips and tricks. As I said at the beginning of the presentation, probably at multiple spots, is that blocking is normal. A key thing about blocking is that before it was a block, it was a lock, and that lock could have been going on for hours or even days before it blocked anything. So if you are going in to kill a block, that should not be your first step, and I'll talk about that in just a second. But a SQL session often executes many different SQL statements, and by the time another session gets blocked, the lead session that is doing the session itself has moved on to something else. The statement that is blocking is not going to show up in the list of SQL. So when you see a block alert, it's going to have a SQL statement in there, but that's just the SQL statement that was last recorded for that session. It's not the one that's doing the blocking. It's not all. It's hardly ever. There are some times when it is. So your best bet to figure out what is actually doing the blocking is to look at the victim sessions and the activity coming from the application that is being slowed down, and that kind of gives you an idea what the blocking is. And definitely don't kill blockers as a first step. You have to find out what it's doing first. If you kill, and remember I said that the blocks start out at locks, if you kill an update that has been running for 6 hours, it'll take at least 6 hours more to roll it back, and the blocking will continue the entire time. So if you come into a block that's been blocking for 30 minutes, look at the session to see how long that session was actually doing its locking. Because if it's an update, you're not going to get 30 minutes back. You're going to spend the entire time it's the entire time it was blocking will now be the time that you're spending waiting for it to get undone. So find out everything you can about the blocking session. This is going to be important not just for what's going on now, but it's for the future, because it's rare to figure out the root cause of blocking with just one example. Most of the usable information will come from the JDE application, as well as actually from interviewing the users attached to the processes, so you can see what they were doing at the time. And whenever possible, you want to resolve blocking from the application side. And that could be something like killing an OS kernel, having a user sign out, or just finish their transaction, or wait for the process to complete. Don't be impatient. Now, if you're able to handle outside the database, that almost always clears the blocking. And you can verify this by rerunning a script on the database and going back through the troubleshooting. Now, with some applications, it might not be possible to trace it back to a specific user or process. And in that case, you just have to make a command decision based on all your available information. If you couldn't find the originating process and the SQL ID is sitting idle and the read-write stats are static, you're probably going to be okay killing the session. But on the other hand, if the blocking session is actually doing an insert, update, or delete, that makes it a lot more complicated. The offending process could have been updating the database for hours, as I mentioned before. Could have been doing this for hours before it ever blocked another session. Kill a session like that, you're stuck with blocking until it rolls back. It might be better to suffer through the blocking until the session is done, especially if you know it's going to be done soon, because killing an update session can turn a 20-minute blocking problem into a 4-hour downtime. So like if you have an update that's been run for 6 hours and you know that there's 2 hours left, you have to wait until that's done, until it's finished doing its update, because you'd rather have 2 more hours of downtime than 6 extra hours of downtime. So let me tell you a little, now I'm going to tell you what we do for blocking. We have our little flow chart here, which you can see, and don't worry about it being too small. I'm going to go through the little sections independently. What we do for blocking at first, we actually, every client we have gets a full analysis of their entire architecture, and a plan is made to bring everything up to a minimum baseline for configuration and performance. We also install our monitoring tools, including Genius for JDE and Foglight for databases. Once we have that in, we have database baselined, we may have fixed, by that point, we may have fixed a lot of problems and you might not see blocking again, but it still might. So when a blocking incident occurs, everyone gets involved to figure it out. We have this flow chart that you see here, guides us through the triage and troubleshooting and resolution. The team records all the relevant information, compares it to the blocking that's happened before, and as soon as possible, we recommend a fix. And then we test it out and we make the necessary changes. Unfortunately, what is often the case is in the beginning, all we can do is temporarily make things better by clearing out the blocking somehow. This is, we got to do this to bring everything back up and running, but it's an important step in getting to the root cause. When you have all that information cobbled together, we can compare it to past incidents, and we might be able to find, sometimes we can find out the root cause right away, but other times it could take a couple weeks or even a month to figure out where the root cause is coming from and allow us to test and implement a change. Here's the chart. We consider this our own best practice, and it's applicable to any application, not just JDE. I know it looks like a reading test still, but I've got the next sections coming up right now. All right, we get a blocking alert, comes in via email, through Genius or Foglight or whatever. The triage flow starts. Now, blocking isn't always an actual problem, so we don't want to mobilize the troops if there's not if there's not anything going on. So the first thing we say, is this a watch list blocker? Is this a blocker we are for either for our client or a known blocking that we know is going to cause problems? And if it is, we just immediately jump to the triage. If it's not, are there any issues reported? Is anything bad happening? If not, then we move on to the next step. If it's obvious that there's something bad going on, then we shoot right to engaging. And this is an important moment to stop and say, blocking can't be predicted at all. There's no way to prevent it from happening. And sometimes the issues you have reported for blocking come in before you know that there's any blocking happening. So anyways, let's say in this incident, there's no issues reported. The next thing is this the first or second alert that you've gotten? If it's a first alert and you haven't seen any issues, then wait to see if there's a second one, because maybe this is just a long blocker that is benign. All right, so if it's the second alert, then we're like, is this one we already know about? We know this is a blocker. If not, start triaging. If yes, then is that known blocker going longer than it's supposed to? And if not, if we get all the way to the end of this, we're probably looking at something that's not going to be an issue. This is a blocker that's not a problem for now. But you still have the opportunity to go through the blocking triage into actually troubleshooting. So let's say we did find out that this is some kind of bad blocking, and we're going to go on to the next step. On the CNC side, so this goes to CNC and the DBA at the same time, but the CNC side, we'll take a look at the alert, and if it's a properly constructed alert, it's going to provide all the information a CNC needs, including server and workstation where it's coming from, the process ID that owns the database session, and that's leading the block. And then the CNC can immediately go into Server Manager, into Genius, into the enterprise servers themselves to find out what the situation is from their side. It's a little bit different depending on where the block comes from. We've got arrows pointing all over the place to where they should go. Now, if the CNC doesn't have the proper information, then the DBA will be logging in at the same time to give them the details on the SQL statement. So they shoot out, get all their troubleshooting done. As the CNC does their thing, they'll be communicating with the DBAs to stay updated on the status of the blocking. And eventually you get down to the blocking continues decision point. And if it's gone at this point, you've killed it from the application side and the blocking disappears, then you're done. And if it's not done, we'll talk about how this ends up in the next couple slides. The DBA troubleshooting steps look a little more simple. There's not as many ways to go off in different directions, but this has happened at the same time as the CNC. DBA also looks at the alert, and if it doesn't show the correct info, they're going to log in and get it for the CNC. Once they get that, they'll pass it on if they need to, but regardless, they need to look at what the blocking statement is, because there's some types of blocking we want to kill right away, and the biggest one is a next number blocker. And the reason that so if we have the blocking statement available and it's a next number, we want to kill that. If this is SQL Server, there's a special case called the fetch API, and that fetch API is kind of a buffer that holds SQL statements that come from a sub-process. So it shoots it over to this buffer, and so if you see fetch API in the SQL statement for a blocker, you can actually find that with a special query. But not always, because the buffer empties itself pretty quickly. If the blocking is going on right then and the fetch API buffer hasn't recycled, and because the SQL statement itself, the SQL session is still young, you might be able to find the associated query. But if it's been too long and the buffer's been cleared, you're not going to see the SQL statement for the lead blocker in that case, and it makes it difficult to figure out what the root cause is. Now, talking about next numbers, you want to kill a next number blocker as fast as possible, because some of those next number calls happen, like I said, 100 times a minute. And if you don't kill a next number blocker as fast as you can, then all of a sudden you're going to have 100 lead blockers, because they all come in wanting to get something, and then they're all going to time out, and you're going to be killing blockers for an hour trying to get out of this problem. If you do kill the database session, or you are able to kill the database session, maybe it's obvious read-only, and it's not doing anything, it's not expending any kind of effort, then you could kill the database session. Then at this point, you update the CNC and wait for next steps. And this gets us to resolution. And at this point, we get to a point where, like, there's still blocking, we can't clear it, and it's usually because it's an update statement, or maybe we don't know what it is because of the fetch API, but we need to make a decision. And if it's an update statement, the client has to approve this, because if data is in the process of being changed on the database and it gets killed, you can introduce integrity issues and business continuity issues due to the difference in what the application thinks should be there and what the database has put in there. So we always wait for the client to make the call. If that's not possible, we may have enough information to kill it on our own, but we generally don't want to do that. The client needs to make the decision to kill any update statements. And that can extend troubleshooting time and resolution and returning the system back. But that's just a liability you don't want to take. You want to make sure whoever owns that data is the one that decides to kill it. And you give them all the tools they need to make the decision, but let them make the decision. Now, if you get to this point and there's no more blocking, then you get to go to the big green pill up there and you're happy you can close the incident. But if the blocking continues, for example, you kill one blocker and another one comes up right behind it, then you got to go back through the triage tree again. I include some frequently asked questions on blocking for people who see this. Why don't we just kill the blockers as soon as they appear? It'll make the problem much, much worse and create liability for you. And this includes creating an automated process to kill blockers over a certain duration. You don't want to ever automate block killing because you will end up in a situation where things go terrible. Your automated block killer could kill a statement that has been writing for 6 hours, as I have said in multiple examples, and then your database is completely halted and you don't know why because the block got killed automatically. And you go in and restart your database and it's not working and you still have blocking. The blocks will never go away. The database has to roll that stuff back. And restarting the database doesn't change it. It will always be doing that. So make sure you get human eyes on every block that you feel like you're going to kill. I mentioned why already we want to kill next number of blocks. It's because there's no way to fix that. You gotta free those up as fast as possible, or else you're going to have worse problems on your hand. You can't alert on blockers in advance because the only time you know a blocker is blocking is when it's actually blocking something. And there's no point in alerting on locks because there's too many of those. And there's no way to stop blocking at all. It's part of how the database works. Database has to block, otherwise you're going to have integrity issues with your data. So if you were to actually see a stream of all the locks and blocks that happen on a database, you would be blown away because there's just too many. So how do you fix blocking? Are you sitting on some blocking that's really painful? It's causing issues with your processing and you haven't been able to figure it out? Well, we can help you with that. You can start with a database analysis, and I got a little example of some of the recommendations from a sample analysis. We implement all those recommendations and baseline your system. Make sure it's a good starting point for the performance of your application. Then we'll put our monitoring on, and then we watch it, and then we wait for alerts to come up and wait for the blocking to come up. And as soon as a block comes in, we dive in, get all the information we can, and hopefully sooner rather than later we correlate all that stuff and fix the problems that you've been having with blocking. We've had a lot of success with this approach. We've had many clients come to us with blocking they've had for years that no one could ever figure out. And sometimes it takes a couple weeks, sometimes it takes a couple months, but in the end, we always figure it out. Sometimes it could be something in a configuration, or it could be something to do with a networking architecture that in another country with a bad VPN, or you never know. We've seen many different causes of blocking. And that's all for me.